DevCentral community, it is that time again. It's Thursday at 12:30 Pacific, and this is DevCentral Connects. I'm John, and this is Jason. How are you, my friend?
I am fantastic. How are you?
Well, you know what? I don't know that I could be much better, So there was a guy I used to know. I would ask him that. I'd be like, hey, man, how's it going? And he'd be like, man, if I was doing any better, I just wouldn't even know what to do with myself. And I was like, I don't know what that means, but it sounds pretty fantastic. So there we are, man. There we are. Well, this is it's always great to connect with everybody out there in the DevCentral community. And we're streaming like we always do to YouTube and LinkedIn and Periscope and all the places, right? So it's fun. So make sure you interact with us, type in some questions, and we'll highlight them here and connect with everybody. So it's gonna be a great show. But so Jason, like I normally do, I have a question for you as we start today.
Okay.
So here we are in the summertime. I don't know if you've been keeping track of the heat wave that has hit our friends up in the Pacific Northwest, but they're in like the triple digits. I was talking to one guy in Canada, and Canada does the centigrade, the Celsius, temperature scale, while we here in America do the Fahrenheit. Which, as just a small aside, I've grown up with the Fahrenheit, but the centigrade, the Celsius, makes a lot of sense in my mind. 0 is freezing, 100 is boiling. That makes sense to me.
It does make a lot of sense, but there's something like when you hit 100 degrees, there's something that's like, wow, that's pretty hot. Whereas it's like, well, I just cracked 37. 37 doesn't really sound that. It doesn't really sound that hot.
How impressive is that? It's like we're still in double digits. I don't know what to do,
That's
so
right.
yeah, but he told me, he said it's going to be 40 degrees up here during that crazy heat wave. And I was like, dude, 40 is not that hot at all. I had not done the translation or whatever, but yeah, it's crazy stuff. But anyway, so here we are in the middle of summer. There's been a heat wave going through. And so one thing that's been on my mind is, of course, ice cream. And we were talking, in fact, our guest today, we'll get into this maybe here in a minute, but it made me think about a conversation I had with my daughter and one of her friends just the other day.
Okay.
And her friend, we were talking about ice cream flavors, and her friend was like, the only ice cream flavor there is like the mocha coffee flavor ice cream. And I was like, that is crazy talk. Now, granted, I'm not a coffee fan myself, which is maybe that's, heretical to many people out there. But anyway, my favorite ice cream flavor is the cookies and cream, the Oreo, flavor. So I wanted to ask you, what's your go-to flavor when it comes to ice cream?
Man, I'm pretty plain vanilla. Like the Chick-fil-A Ice Dream. I know it's probably not ice cream at all. They whip some powder together and all, but I really like that. But if we're going flavors, probably banana with, like vanilla, but with bananas and some caramel sauce, and just mix that up together. And that's kind of my go-to treat. But incidentally, I don't really like ice cream that much in the summer when I'm hot. I'd rather have it in the winter when I'm cold, which is weird. I know, I get it, but that's
yeah, we could have an entire, hey, join me on the couch and let's kind of psychoanalyze that and whatever. So yeah. That's crazy stuff, man. Wow.
So 43. Yeah. That's
43
crazy.
Celsius. I mean, that's like probably Fahrenheit. I don't know. I don't remember the translation
37
number.
is right around 100. So yeah, you're going up higher than there. Yep.
I mean, that's over 110.
That's probably 110. Yeah.
Fahrenheit. That is crazy hot. I don't care who you are. That's hot. Shoaib. So yeah. Awesome, man.
Hello, Eduardo.
Eduardo Ochoa, hi from Mexico. Hola, our friend. So good stuff, man. Good stuff. Well, yeah. So anyway, one thing really quick about ice cream, not to go on about ice cream, but it makes me thirsty. Every time I eat ice cream, it's like, I got to have some water. So maybe that's part of your, if it's hot outside,
yeah,
it just makes you like super thirsty. So, and it's like, I'm hot. I don't want to be thirsty. I want to like quench my thirst. So anyway. Good times. All right. Well, good to go, man. Well, hey, so I know we've got an awesome show today. I know coming up here, we've got next week, not to look at next week too much, but we've got our MITRE attack framework. Yeah, it's going to be really cool.
Let's kind of follow up. We'll have Sander back, as well as Jamie C. Williams is going to be with us from MITRE, and so that'll be a good show. Kind of a follow up to the App Protect report and how Sander kind of customized that for his use. But yeah, that'll be really good. And then on the 15th, you got
security sidebar. That's right. All things security.
Yep. And we're back the 22nd with John Capobianco and Dan Pacheco. Were with us several months ago. They're going to come back and join us and catch us up on the crazy stuff that they're doing with automation in their environment.
Yeah, and they do amazing work.
Yeah, so that's what's coming up in the next 3 weeks. Yeah, we actually are doing a little back-to-back with DevCentral Connects. Normally, we're kind of alternating, but because of schedules and all that, vacations, we're doing a back-to-back this week and next week, and then we'll kind of get back on track after that.
Yeah, that's awesome, man. Yeah, it'll be a lot of fun catching up with everybody. It's MITRE Attack, and then Capobianco and Pacheco. Those guys are awesome. If I remember right, and I'm going to need to kind of hone my skills on this, but Capobianco is a dad joke aficionado, if I remember right. So we need to make sure we bring that the strong dad jokes that day. So. Good stuff, man. Good stuff.
And I probably need to get better at dad jokes, because for Father's Day, my oldest daughter gave me I keep my dad jokes in a dad base t-shirt. So now I'm not going to be able to wear that out in public unless I got a good stock of them up there upstairs.
Yeah. So. Yeah, people are going to be like, Jason, how big is that database really? What has it got? One entry in it? That's it. So
the go-to,
yeah, that's it. Good stuff, man. Good stuff.
Well, today we're going to talk about AWS Autoscaling with Terraform with Tyler Hatton, who you may know from our lab shows that we've done. We've done 3 of those, and we did them with Tyler. Previously, he was with a different company, but now he is actually one of us, so we get to give him a hard time, more so than when we had to be nice because he was an outsider. But now that he's family, we can just kind of pound on him a little bit and do that. So we're going to bring him on here in a minute. But first, we started a couple shows ago this Today I Learned, and I had learned something, and I wanted to share that. So today's one of our teammates, Leif Zimmerman, had something to share about spy trackers.
Hey there, DevCentral community. This is Leif from the DevCentral team, and today I learned about spy trackers in email. Little bits of code, or maybe 1x1 pixels that track your behavior and maybe violate your privacy in all kinds of ways that you don't want. So I'm demoing this product from hey.com, an email service, and turns out they strip it or maybe block it for me. So, +1 on the privacy front, huh?
All right, Tyler, welcome to the show. Welcome back to the show, I should say.
Well, thank you. Hey, guys, how's it going?
Tyler, a fellow F5er, man. Good to see you.
Yeah, I got my F5 shirt on today.
Right, you're sporting the red F5 ball.
Exactly. Yeah. Hopefully not hurting anybody's feelings, but we'll see.
No.
And by the way, I'm ready for the gauntlet. I'm ready for my beatings. So let's do this.
It's like, hey, you can't beat up my brother, only I can beat up my brother, right? Kind of a thing,
Exactly.
That's right.
So don't pick on him. Good stuff, man. No, man. Hey, we're excited to have you on the F5 team. This is fantastic. So
absolutely.
Yeah, good stuff.
So what are you here to talk to us about today, Tyler?
Yeah, so absolutely. So the whole topic of today is to really talk about kind of AWS autoscaling groups and kind of some tips and tricks on kind of some practices that you can adopt when using autoscaling within AWS to manage your big IPs. So I've been playing around with autoscaling for the past couple months. I found some cool features I haven't seen a lot of people use, and I kind of wanted to point them out and talk about it and really kind of talk about the potential value there could be for organizations to use them.
Cool. Well, do you want to get into it?
Yeah, absolutely. Let's do that. So By the way, guys, I heard about your next couple episodes, and I'm super excited about the Canadian Parliament one. Their last one was awesome. So,
Yeah.
bit of a fanboy. Pretty excited about that. But before we kind of go into at least an overview of what we're going to talk about today, what's really cool is everything that I'm about to talk about. There's code to back it up. So if I do a poor job explaining kind of the different features of AWS Autoscaling, or you're just trying to get a better understanding of what the heck was Tyler talking about, I have the code posted on GitHub right now. You can pick apart my GitHub project. You can use the pieces that you're interested in. You can remove the pieces you don't care about. Feel free. It's open to you. And I'm sure we're going to post a link in the chat. So kind of calling that out. And then the other thing I want to call out too is there's also an article about kind of the larger topic that I'm going to talk about, which is AWS Autoscaling and Big IP, that I posted to DevCentral, I guess 2 weeks ago, because it's on the page. And if you kind of want a better explanation as to what I'm about to talk about around these different features of AWS Autoscale and how Autoscale works, definitely take a look at this article. Just another great resource. Again, try to enable the larger DevCentral community to kind of pick up these different features as they use Big IP or scale out Big IP in their own environments. And then the final two things before I actually go into the content today, because I do think I'd be remiss and I'd be doing a little bit of a disservice if I didn't bring up these two different resources. And that's around the official AWS CloudFormation template. So this template that I have right here, this is kind of my own opinionated way of doing things. I took a lot of what I liked in the official Big IP or F5 Terraform module or Terraform template, used a little bit of that, and then made some customizations. If you're looking for something more official in your environment, just recently, an AWS CloudFormation template was posted around F5, and it's on GitHub right now. It was released back in May. And then the other thing to call out is the actual Big IP module that's on the Terraform registry also. So calling out all these different resources, just great resources that you can look at. And if you're brand new to Terraform, if you're trying to figure out how the heck do I deploy Big IP inside of AWS, it's a mystery to me. I mean, it certainly was for me a couple months back or a year back. How do I do that? You can take a look at these resources and kind of make sense of it on your own. Or you can reach
kind of on that before you jump into what you're going to share. How do you do your discovery? Like, what's your process for just discovering in whether it's AWS or Azure or Google Cloud? What's your discovery process to find stuff like this? Because I know that if you log into AWS console or any of those things, I mean it can be overwhelming, right?
Yeah.
And it's kind of like there's I don't know, what's the show, Brain Games or something that they had, where it's like if you are offered 3 flavors of ice cream, we'll stick with the topic today. If you're offered 3 flavors of ice cream, your brain is very quick to pick one. But if you like go into Baskin Robbins and you have 31 options, you may sit there in analysis paralysis forever.
Yes.
And so, and that's kind of the case of things like, AWS console and other consoles. Like, there's so much in there. It's like, where do I even start? And how do I get involved and get started?
Yeah, that's what they call it. Is it the paradox of choice? There's so many different options that it overwhelms you, so you don't know where to start. And that's an interesting question. And I have a couple answers to that. So I would say, generally speaking, if you have a specific use case around AWS that you're looking to solve, there's an incredibly good chance that somebody has tried to solve that same use case in the past. And I don't mean to be that guy, but that's kind of where Google does come into play. Searching GitHub, searching Google, really looking at the other projects that, other organizations or people have built very similar to this Big IP Terraform module that's on the Terraform registry today, which is a great resource, the Terraform registry in general, where you can actually look at this code. And in fact, we can do that right now and see from a Terraform standpoint, kind of what are the best practices that at least F5 has applied when spinning up F5 resources inside of AWS. And by the way, there's a similar resource for Azure and GCP. So that's for a very specific use case. I want to spin up Big IP inside of AWS. Now, the other side of that, and answer to that question a little bit, especially when it comes to AWS, is so AWS today has 200 plus different services, but realistically, most people, most organizations, they're only going to use maybe less than a quarter of that. And people can disagree with me if they want on that, but realistically, there are a group of core AWS services like EC2, which we will show a little bit later, where we're running our big IPs, IAM, S3, understanding what a VPC is, core services that you really have to understand that are almost universal throughout AWS. And I think a good place to start in picking up those concepts, at least for me, was kind of going through the AWS certification program. But not only that, actually, building out things on my own, again, figuring out how the heck do I build out a big IP inside of AWS? What services do I need to use in order to build that out? And through that discovery process, through that path of exploration on your own, and through a little bit of a guided tour, which is that whole certification program, I think that gives you a better ability to at least understand, hey, in order to solve this specific use case, to build this application that I'm building, these are the services I need to use. So long drawn out answer there, but at the end of the day, Google is your best friend. I've been at this for almost 10 years now. It's amazing how much I've been able to solve with just some basic Google searches. But if you're looking for something more guided, I think the whole AWS certification program, if you're willing to truly practice kind of what it preaches, I think is a great place to start also.
Yeah. Hey, real quick, if I could rant for a second.
Oh boy.
you bring up Googling, and I've noticed a pattern, and maybe it's just because I've been looking through Twitter streams a little bit more, and they're always there. But in the last several days, I've just seen so many people gatekeeping on it's not a real engineering interview if you didn't sit for 3 days. You're not a real software developer if you have to look at Stack Overflow. And, that's ridiculously frustrating, because the reality is it's like, you don't get paid because you have all the answers up in your brain. You get paid because you know how to find the information you need to solve problems, right? Mm-hmm. And so tools like Google, like Stack Overflow, like your peers in your work environment, it's not a bad thing to reach out to them. And so all you gatekeepers out there, knock it off, stop it.
Hey, in fact, Jason, not only is it not a bad thing, it's a good thing, right? To reach out and use the network, use your connections. That's right.
Yep. So let's be community. Stop tearing people down. Let's be community. Yeah. Let's lift everybody up. Let's stop tearing people down. Anyway, nice. I'm off my soapbox. Continue, Tyler.
Well, so really quick, and it's hopefully this is new to the folks that are watching this, or most of the folks, but to the whole point around Stack Overflow and this concept of you're not a real developer, you use Stack Overflow. Everybody uses Stack Overflow, but GitHub earlier this week announced this new project, or this new extension of VS Code called GitHub Copilot. And basically what it is it's kind of like an AI extension of VS Code, where it tries to auto build your code as you write it. So as you start typing out your code, it tries to figure out what you're doing and auto complete that code. Kind of similar to like a command line, if you use Bash or like ZSH, is trying to figure things out for you. But where they get this data, and they've said this, at least in the articles and the tweets they've used to describe how this works, is they use Stack Overflow. So the reality of the situation is, I think the future of working in development, whether you like it or not, you're probably going to be using Stack Overflow or something very similar to it. Copilot very early on right now, but I mean, this is neat. I think something like this, while it's not going to be able to solve all the development problems that are out there, it'll certainly help kind of augment developers as they try to build out their pieces of code. So kind of calling this out. Cool project.
Yeah, that's crazy. I may have to play with that.
Yeah,
it's a little freaky. Some of the AI stuff's just, it really is a little freaky. I'm sure we'll all get used to it, but
Yeah.
Well,
Early on, it's like, how much do you know about me, and how did you learn that? Right.
Right.
Yeah. Tyler, tongue in cheek, I was going to say, does this auto write your programming and like create lots of, compiler errors, and the code just doesn't work when you're done? Like, is that, as you would when you write it on your own, right?
So that's a downside of using Stack Overflow, right? So one of the criticisms I've always heard about Stack Overflow is, at the end of the day, the best voted piece of code or the solution to the problem that's on Stack Overflow, sometimes it isn't the best solution. But when I was reading the tweets about this, I think they used a lot of that data to kind of at least populate the code as it was putting in front of you.
Yeah, I'm sure they use the number of thumbs up and stuff. Hopefully, I mean, they use the number of thumbs up against the samples, not just the samples themselves.
Right.
Because there's some that have like 60 thumbs up, and then there's a few that have like 5 negatives. Is the best answer. I mean, the best that they could do is 5 negatives. Like, you probably don't want to use that code.
Right.
But I do find sometimes the community feel in Stack Overflow can be a little acerbic sometimes, and it's like, come on, guys, or just try it for a question. Particularly if you're new and you're asking a question for the first time, you get the editor overlords that come in and yell at you for not asking the question the right way. Yeah.
There's always those people. Yep. Crazy. Don't be that way, though, right, Jason?
That's right. Don't be that way. Be nice. Go be nice. That's in fact, I think it's my mother-in-law used to tell her kids when they'd go out, it's like, go be nice. So
go be nice.
That's right.
That's good advice.
Don't be evil. That was Google's big thing. I think it still is.
Used to be. No, I think they've removed that.
They're no longer interested in not being evil.
Well, good thing we're not talking about GCP today. So.
Okay, that's right. Yeah, fantastic. Yeah, right after we said Google is like our savior for giving us information, right?
That's right. Absolutely. But one final thing I actually forgot to bring up a second ago. So John and we did an overview of Terraform, late last December, I think.
I think that's right.
If you're brand new to Terraform, if you look at this code that we're going to show a little bit later on, or you look at this repo that we're sharing and you're like, what the heck, how's this whole thing work? We did a full Terraform overview a couple months ago, and there's actually an accompanying lab that's on WWT's website that you can take a look at. So for the WWT folks that are potentially watching, there's your plug.
Shout out,
pay me afterwards.
That's right. Hey, we can link to that too, like down in the little comment or description. So that's a good place to start.
Yep, cool,
absolutely. But kind of going back to at least the code and to talk about kind of an overview of really auto scaling in general, I thought really just a general good place to start is, what does a traditional big IP architecture look like today, and how does it differentiate itself from kind of the auto scaling model that we're seeing kind of organizations slowly pick up, especially within public cloud? And this is mostly a review. I won't spend too much time on this, but general traditional architecture of a big IP device is kind of similar to what you see on the left-hand side right here, right? So we have kind of our basic active and standby pair, and during a failover scenario, where let's say our active device fails, we'll make this one the active, so it's no longer the standby, and then we'll send traffic to that big IP to our backend application. So very, very kind of straightforward, right? 2 different instances. One fails, the other one takes up slack, and hopefully everything goes smoothly. And usually it does. In between that, you usually have this heartbeat connection in between. And in the case of public cloud, to kind of call out at least a key difference is there's this thing called the F5 Cloud Failover Extension that was introduced fairly recently. And if you are looking at doing kind of your traditional active standby pair inside of like an AWS, for example, you're going to probably want to look at using that CFE or that Cloud Failover Extension to kind of handle that failover process. Because basically what it does is it uses things like the Elastic IP to shift traffic from one instance to the other. It makes things a little bit smoother, or at least for public cloud. So kind of calling that out. But looking at this overall architecture, as we talk about autoscale in general, the thing I want to make clear is there's nothing wrong with this architecture. I've personally seen a lot of organizations as they go into an AWS, they still continue to use a basic active standby type of architecture, the exact same thing that they did on-prem. And I think part of that reason they do that is that's what they know, right? They know active standby, they know how it works, and if they're doing a lift and shift of their applications into public cloud into an AWS, it makes a lot of sense. So as I talk about Autoscale today, realize I'm not beating up on active standby. I don't think there's anything wrong with it in most situations. It's just it's a use case. But kind of looking at this architecture and potentially one of the downsides of it is we look at this kind of standby instance, and let me clear this out. What is that standby instance doing? You're paying for it every month. You're paying for the compute. You're paying for the storage. The network cost probably isn't that high because there's nothing running through it, but you're still paying for it, right? And what I've seen, at least from some organizations, is they're like, well, we have the standby instance running inside of AWS. Say, what value does it give us? So that's kind of one of the reasons why we could potentially want to look at Autoscale is, just have a standby instance there. It's sitting there doing nothing. The cost is probably relatively small compared to your larger AWS bill, but it's still an instance where it's a question of how do we maximize our spend? And that's where something like Autoscale comes into play. So high-level architectural overview of how Autoscale works, and apologies for the folks that have seen this before, but making sure everybody's in the same playing field. But basically, the way that Autoscale differentiates itself from kind of our typical active standby architecture is instead of having just an active standby, we effectively run multiple different active instances of our big IP devices. So that's why I put that A there. And instead of having the user go directly to our big IPs, usually we have some type of what's often called a tier 1 load balancer, or an NLB in our case, or a gateway load balancer in some other cases, that basically sends or evenly distributes that traffic across our different big IP virtual instances that are running inside of AWS. And for the folks that are kind of unfamiliar, or at least with that NLB or that network load balancer, it's kind of like, not to beat up on it, but it's kind of like a dumb layer 4 load balancer, right? It doesn't do a lot of the layer 7 or application layer capabilities or WAF capabilities that something like an F5 can do. It's really just doing two things. It's checking the health of these different big IPs. So it's kind of doing a very similar health check that you would see on an F5 device. And then the other thing that it does is it just sprays packets evenly, round robin, across your F5 big IPs or your virtual big IPs inside of AWS. And then you pass it through your big IP. You might be using it as a WAF. We commonly see that. And then it finally sends that traffic to that backend application. Mm-hmm. So hopefully pretty straightforward. And this is often, by the way, what's called a tier 2 load balancer. So tier 1.
That is shocking, Tyler.
Yeah. Hopefully
Tyler,
pretty straightforward.
Where did you get the tier 2? I don't understand. I'm just kidding. Hey, it is kind of ironic, I guess, that we're talking F5, big IP, historically the load balancer, and it's like we need a load balancer up there to, send. I just find that kind of awesome.
To load balance the load balancers.
Exactly. It's just the world we live in and how networking works, at least in AWS.
It's what it is. That's right.
What it is. But the power of kind of this group of devices and the power of running it in this active sort of cluster is, first of all, we can take an instance out of this group, any of the instances, whenever we want. We can use the NLB to slowly drain connections off of it, or if it goes down abruptly, the amount of impact is probably fairly low. So that's the first nice thing. And a little bit later on, we'll talk about upgrades and kind of how running an active sort of Autoscale group is really nice for upgrades. But the second thing that's really nice about kind of running it in an Autoscale group and kind of this active setup is, clear that out, we can effectively scale out and scale in our infrastructure based on the requirements of our organization. So, let's say that we're a big, massive retailer, and it's the day after Thanksgiving every year, It's Black Friday. You're seeing this huge influx of traffic. How the heck do we scale out our big IP infrastructure that might be providing a WAF? How do we scale that out in order to meet that customer need? Or another one, maybe you're a healthcare provider. I used to see this all the time where it's open enrollment and you're seeing a ton of new users come to your website. How do you scale out to that need? A lot of organizations kind of have this type of peak traffic every year. My old organization worldwide, when I worked in IT, it was Cisco year end. We had to do a change freeze. It was a big deal. Ton of orders would come in. But basically, a lot of organizations have these peaks in traffic. And the big question around that is, how do you scale to that need? And one of the ways that you can do that is, traditionally, right, you could have a GTM up here that could act as your DNS server, and you distribute across your different DNS or your different data centers. That's a little bit challenging. Or you can do what we do right here and kind of use this thing called an autoscale group, which basically monitors the state of our F5 devices that are running in the group. It can effectively detect, hey, we're seeing a ton of traffic right now, and it's continuing to go up. Maybe we need to scale out. Or alternatively, maybe you don't trust the monitoring or the CloudWatch functionality that exists here. You can also dictate and very deterministically say, hey, this is the amount of big IPs I need right now. Go spin them up. Scale out that capacity to meet this customer need that we could potentially see for open enrollment or Black Friday or Cisco year end, whatever that use case is.
Tyler, one thing that I think about is, obviously, in my mind, it makes a lot of sense that as the traffic, as the interest or capacity or whatever, as it floods in for any of those use cases you mentioned, it makes sense that we would want to build this thing out, and so it's like, let's do 1,000 big IPs or whatever, right? But then on the flip side is, it's like when things start to slow down, maybe there's a bit more hesitation to say, hey, let's just kill 500 of our 1,000 big IPs, right? So anyway, I find it interesting and kind of awesome, really, that it's like, hey, we can automatically scale it out, but then also make those good, I assume they're intelligent, decisions to make it smaller as well, right?
Exactly. So yeah, to your point, scaling out when you need it, but scaling in when you don't need it. You don't want to be paying for all that capacity for Black Friday on February 2nd when nobody's using your website. But you kind of, to your point, right? If you want to spin up 200 instances as part of this autoscale group, you can absolutely do that. I think the maximum size from a technical standpoint is 255, but you can certainly figure out ways to go past that. But when you don't need that, you can absolutely scale in. And I think that's one of the beautiful things about public cloud, just in general, regardless of what provider you use, GCP, Azure, AWS, DigitalOcean, you name it, you're just paying for what you're using. So looking into the future, trying to figure out and properly sizing your environment from an infrastructure standpoint and kind of getting this scaling perfect, I think, is going to be what a lot of organizations are going to be looking at as they try to figure out how do they optimize kind of their cloud costs. So yeah, absolutely.
Yeah. Cool.
Before you go too much further, Tyler, we have a couple questions here. From Master Dead 3. Great name.
That's a great. Hang on. This is going to be a great question. I don't even care what the question is.
In auto scaling, is it better to disable last hop for the auto scale?
So at least in my testing, I've always kept it enabled. I'm sure there are certain cases where auto last hop is disabled, but yeah, I've never explicitly disabled it in my cases.
Yeah, I would think you'd still want your flows to go where they came from, right? Which is basically the point of auto last hop in the first place.
Yeah.
So, yep. And the other one here is
case, but I can't think of one.
Yeah, Daniel Wolf, how difficult would it be to use F5 DNS load balancer cloud service instead of AWS NLB and update its configuration using the API? Could Terraform do that too?
That's a great question. That's a really good question. That's a really good question. So basically, have the cloud services of or F5 cloud services update its pool for different NLBs that you're spinning up. I could see you doing that with Terraform. I haven't seen anybody do that in the past, but you could take the outputs of running a change within cloud services, which I'm not even sure if there's a provider for that today, but if there isn't, I'm sure there will be one eventually. But taking the outputs over NLB, so the IP or the DNS name of that NLB, and then porting that into F5 Cloud Services or into a GTM device. Again, I've never seen anybody do that, but I don't see any reason why you couldn't. And honestly, having kind of that solution like Terraform that can talk to multiple different services at once could be used as kind of that glue or that duct tape I often think of to bring those two different services together.
My only concern using DNS on that front is you want to scale now, right? And so you would have to manage your TTLs pretty well with doing something like that.
Yep, absolutely.
Mm-hmm.
Any other questions?
No, you're good to go.
I think that's it, man. Yeah, great question by Daniel Wolf. Always ask great questions, by the way. So appreciate you, Daniel.
But looking at Autoscale, the one final thing I'll kind of call out around this. So looking at the traffic flows, right, just adds another big IP that traffic can flow through. But the other thing to call out too is while this is very AWS specific, that at least what I'm talking about right now with like NLBs and calling an autoscale group or autoscaling group really is a proper term. Again, look at Azure, look at GCP, look at DigitalOcean. All those different cloud providers, they have similar functionality to an autoscaling group within AWS. So again, very, very AWS specific here, but honestly, you can apply these same ideas elsewhere in other platforms. But kind of looking at least auto-scaling at a high level, I think there's really a common set of challenges that I think I've seen at least most organizations run into that have tried to adopt this architecture in their own organization. And I've kind of broken it down into three different things. So the first one is really kind of ensuring a consistent configuration across these different big IPs that we're scaling out as part of this auto-scaling group or scaling in. And really what that's around is, in this case, where we're scaling out right here and spinning up that fourth big IP, how do we ensure that big IP has the same configuration as all the other big IPs that are running in this autoscale group or this autoscaling group? So how do we ensure configuration consistency? That's the first problem we have to figure out. We'll talk about a potential solution for that in just a second. The second thing we have to figure out, and this is something I've encountered in my own testing, is how do we test the big IPs as we're spinning them up before we send traffic to them? So how do we ensure that all the VIPs on that big IP are in a working state? How do we ensure all the services are online? The API is responsive, AS3 is responsive. I ran into cases where AS3 isn't responsive. That's not good. How do we ensure it's licensed? That's a big one. If it's not licensed, you're not going to be able to send traffic through it. How do you ensure that kind of those basic requirements that we need from a F5 big IP device, how do we ensure that we're meeting them? So how do we test against that? And we'll talk a bit about that in just a moment. And then the third thing, if you're using this thing that's called a BYOL license and not a PayG or a pay-as-you-go or pay-go, whatever you want to call it, one of the things that you have to figure out is how do you as an organization, how do you only use the license when you need it and revoke it when you don't need it? How do I build that license application or revocation process as part of the larger workflow of spinning up a new big IP as part of my autoscale group? And we'll talk about that in just a second. So different challenges that we have to think about, different challenges that they're kind of mentioned in that article, but very common challenges that I think every organization, at least that I've worked with, has encountered trying to do autoscale within AWS.
It's kind of cool with that first, at least with the autoscale group layout that you have. I was thinking you can do transparent A/B testing almost with policies or performance-based things in your autoscale group, right? Because you could have, you want to ensure they're consistent, but if you wanted to make sure maybe one wasn't consistent because you want to do maybe some transparent A/B testing, you could pull all the analytics separate from the other devices on that one and do a compare contrast, and then push more policies, almost like you're bleeding some of the connections onto a new one that has the new policy, then the rest of them come up to join it.
Yeah, and So later on, I might talk about a way that you could potentially do that. At least some really quick A/B testing as you're running maybe a new version of Big IP. So, yeah, maybe a preview. Maybe, but kind of going into this auto scaling group, just really quick, what does this look like, at least from a Terraform standpoint, and from at least an AWS console standpoint? And I'm hoping it didn't boot me out. There we go. But kind of looking at my Terraform code, at the end of the day, a lot of what is kind of clicking around inside of the AWS console, one of the beautiful things that at least Terraform does is it kind of makes the process of spinning up an autoscale group very simple. So in this case, what I have is, what name do I want to give it? What VPC do I want it in? What's my maximum and minimum size? So how big do I want this autoscale group to be? But all these are just different variables that I'm providing this autoscale group and spinning this autoscale group that I'm spinning up inside of my AWS environment. So that's what it looks like, at least from a Terraform standpoint. And then from at least the AWS console standpoint, what this looks like is I have my autoscale group, and in this case, I've spun this up ahead of time where I basically have 5 different instances. But one of the cool things that AWS has introduced fairly recently is this idea of a target group and kind of a new interface for target groups, where I can easily go into here and basically see of these different 5 instances that I currently have as part of my autoscale group or my target group for my NLB, how many of them are in a healthy state right now? Where are they living right now? So as you're trying to get more familiar, at least with Terraform and AWS, there's quite a bit of resources to kind of pick apart, what's going on in my environment, at least from a pure operations standpoint. So just kind of explaining, at least going past the diagrams a little bit, what does this look like? If you were to take that Terraform template that I have published on GitHub right now and spin it up, what is it going to show me from a console standpoint? But kind of going back to these new challenges that we see around testing and license management and ensuring a consistent configuration, a potential way that you can solve these is through these things that are really called lifecycle hooks. And in my opinion, I think this is like the coolest feature about an auto-scaling group. And basically what a lifecycle hook is they're events that are triggered when new instances are spun up and spun down as part of your auto-scaling group. So as an event occurs, as a new instance is spun up, it basically executes or triggers some type of code or event against another AWS service to kick off some larger process that needs to happen in the background as, for example, your big IP spins up. And as we look at this diagram and kind of look at the auto-scaling group in general, as we talked about, there's really 2 key events we care about, at least in this case. We care about our scale-out event, so we're launching a new instance, or we care about a termination event, so we're scaling in, we're getting rid of that old instance that we don't need anymore. It's no longer Black Friday, we don't need it. So as part of that, one of the cool things that happens as part of this larger auto-scaling group process, and as part of this lifecycle hook, is you can put this instance into what's called a pending wait state. And as part of that, you can basically trigger some type of event or function outside of just your auto-scaling group. In this case, what I care about is this thing called Lambda. And for the folks that have never worked with Lambda before, actually, if there's a service that you could start looking at from an AWS standpoint, this would be one of them. It's like one of those core services I think anybody should know about when it comes to AWS. But what Lambda does is it basically allows you to write a piece of Python code, for example, and without managing the underlying server or compute or storage or any of that, it allows you to run that code without managing anything in the background. It's serverless is the name of it. So in this case,
I hate that name, but yes,
I love it because it bugs people like you. I love it
because it runs on somebody's server, right? So it's not serverless, but yes, you don't have to manage that aspect of it. You're just deploying an app, not a server, right?
No, I've heard that many times. Talking to a lot of different folks, and it's true. There is a server there, and what was the old sticker? It used to say, was it the cloud is somebody's server or somebody else's server?
Cloud is just somebody else's computer.
Yeah. So, But the whole point why I would encourage anybody to look at Lambda is, ultimately it's kind of the lowest barrier of entry of writing a piece of code and running it in the cloud. In this case, I literally just wrote this piece of Python. I needed some type of trigger. In this case, it was my Lifecycle hook, and away I go. I didn't have to worry about running a VM or an EC2 instance inside of AWS. It just runs, and I only get charged for when it runs. I don't get charged for some EC2 instance or VM that sits out there idle 99% of the time. And I think the beautiful thing about this is that a lot of people are looking at how do you build applications, or they have built applications around kind of these serverless capabilities. I've built applications using Lambda. So if you kind of want a way of at least getting maybe your feet wet just a little bit using Lambda, here's one of the avenues to do that. But kind of looking at this code, talking about this idea of we're putting this instance into a pending wait state, we're executing a Lambda function. What the heck can we do with that? And one of the things that you can do with that is kind of the different, we can use the different features that exist from an F5 standpoint, such as like an AS3, to provide those configurations we were talking about earlier. So as we have this scale out event and we spin up a new big IP device and we put it in this pending wait state where we're not sending any traffic to it, one of the things that we can do is have AS3 go in there, or have our Python function use AS3 to apply a list of AS3 declarations before any traffic is sent to that device. So the thing that I did, at least as part of this repository that I'm sharing as part of this presentation, is I have a list of AS3 declarations right here. They're stored in an S3 bucket, but you can store these anywhere. If you want to store them on an FTP server that you've been running for 15 years, you could do that. It doesn't matter. Store them anywhere. And what my Lambda function does, what that piece of Python code does, that's just sitting there and waiting for somebody to execute it, it takes that AS3 declaration or list of AS3 declarations that live in that S3 bucket and then runs it against that new big IP device that I'm spinning up. So again, the beautiful thing about that is the S3 bucket is almost like my source of truth. The configurations that I need or that I want on all of my F5 devices, it's in that S3 bucket. And before traffic is ever sent to this F5 that I'm scaling out, I'm basically applying these AS3 declarations to ensure that it has that consistent configuration on it. So that's one thing you can do, at least with these Lambda functions and kind of these Lifecycle hooks.
Yeah, that's really cool. Although you're a bold man, making S3 bucket the source of truth.
Make it an FTP server. No, it can be anything. Like if you want it to be GitHub, you can make it GitHub. I'll say that the nice thing about S3 is it's cheap. It's cheap to store things on there, but you can also version your files, and you can do permissioning quite easily between Lambda and S3. But it's what I used in this example. The other thing I forgot to call out too is you don't have to use Python. Lambda can basically use any language that you want to use. So if you want to use Go or Node.js or Java, if you're a Java guy, you can write your Lambda functions in those languages. So
you chose wisely, though. You chose wisely.
Exactly. So it's up to you, right? And how you want to write this. It's just what I chose as part of this process. And then the other thing to kind of call out too, just around the second challenge that we had discussed a little bit earlier, we've applied the configuration, but we need to test this thing. Before we ever send any sort of traffic to this device that we're spinning up or we're scaling out with, how the heck do we test this thing? And one of the things that you can do as part of these Lambda functions or as part of this Lifecycle hook that you've kicked off while this thing is in this pending wait state is you can run a certain list of test cases against the device in whatever language you want to use. Maybe there's a test framework that you prefer. But as part of that, it will basically run those lists of tests, maybe checking a list of VIPs. And to kind of show the workflow, what will happen is basically one of two things. So you're either going to be in a failure state or a success state, right? Either your test is going to work or it's not.
Right.
And in the case of at least a failure state, one of the neat things that at least autoscaling does is it basically terminates the instance that wasn't working properly. It's like, well, this is no good. It's the bad apple of the bunch. Does that make sense? I think so. And it terminates the instance and it retries, right? Until it gets an instance that it likes that can match or that can pass all the tests that you provide, at least as part of that Lambda function or whatever code that you've written. So, kind of speaking at least of the high value of this or high level value of kind of this process, ultimately what you're doing is just ensuring a certain level of quality of the big IPs that you're spinning up. You're ensuring that there's a good chance there isn't going to be a big IP that's part of your autoscaling group that the NLB is sending traffic to that isn't working, that isn't passing traffic, that maybe isn't blocking a certain WAF or blocking traffic for a certain WAF policy. It's meeting a certain level of quality, and hopefully your users see less errors because of it. So it's one way to kind of solve that problem, at least from a quality standpoint. Hey, while you're in that pending wait state, let's do some tests against that big IP and see if it can pass it.
Does that particular terminate instance qualify for a scale-in event so that the license get revoked?
That's a good question. It should. So it should treat it as a terminate right here. So,
okay.
And we'll talk about the revocation. Yeah, it should. But actually, I haven't tested that. I should test that. I'm going to test that after this. But no, that's a good question. I think so. But something I need to test. But
I would think so because, right, it's already launched the instance and it's in the pending state because you want to do things before moving into the service, right? So I would think that it's going to take care of that and then, give you a scale-in event. That would be my guess. That's my hypothesis. You can report back once you do the testing and let me know.
Scientific method and all that, right?
Yeah, and unfortunately, I'm one of those people that's always, I don't know, but I should probably test that before I give you a solid answer. But I think so. But to that question, so if I go back to my other screen really quick. So earlier today, I was actually scaling out the capacity of my autoscaling group just to kind of present this and show this whole thing off. And as part of that, I actually had an event where if I go into activity under my autoscaling group, I had a failure. So it detected, hey, as part of this process or this Lambda function that got kicked off, in this case, I didn't hear a response from the Lambda function. But as part of the function, you could also say, hey, you didn't pass this test and fail it out also. And when it did that, it actually say, hey, I canceled out this step of the process. And in addition to that, it actually went through the process of terminating that instance. And I think it's the same instance ID. It is. And it told me that as part of this activity log that's within my autoscale group. But if I wanted to dig into this a little bit more, I could actually look at the code of the Lambda function and ask the question, where the heck did this thing fail? Or I could actually get notifications on it too. So there's a whole notification section right here if I want to use the native notification mechanism, or I could again build it into my Lambda function. You can do almost anything with Lambda. But again, talking about the idea of just ensuring quality or ensuring that my F5 instance is working before I bring it into service, that's what happened here. It wasn't working. It identified a problem and it basically sent it to termination into a termination event and spun up a new one. So kind of cool, I guess.
For sure.
Nice.
So just a level set, we got about 6 minutes left of the hour. We're already really close to the end. So I'm fine to go long if you have a little bit of time, but I just wanted to level set with the time, because it's crazy that we're already at 3:24.
I know these things always go by super fast.
Yep.
I always joke with you guys. I'm the worst person at estimating time, but
it's like it'll be about a 15-minute discussion, and which it is. But then we got to answer questions and expand on those, right? So,
absolutely,
good stuff. No, it's good stuff.
But kind of going back to it, at least, okay, we hit a successful event. What happens here? oops, let me go back. There we go. In this case, right, it goes into an in-service event and goes further down the lifecycle process, and then you're in service, you're available. We can now send traffic to it. So that's kind of the larger picture of at least what we're doing here. We're applying the AS3 declaration, then we're testing it, and we're testing the device and ensuring that it can pass traffic. And then once we pass that test, then we can bring it into an in-service state and we're ready to go. And then to kind of that third problem I mentioned earlier. So the other cool thing that you can do, at least part of these lifecycle hooks, is you can also execute Lambda functions or external triggers based on a termination event. So let's say you do have that case where you're using a BigIQ license manager as your source of licensing, and you're using bring your own license or BYOL. Well, one of the ways that you can basically control when licenses are revoked and applied is by using these lifecycle hooks. So when we get to the point where this instance is finally being terminated, we can actually revoke that license. We can have Lambda reach out to BigIQ and effectively terminate that license inside of BigIQ. So again, kind of cool. If you kind of think about how this whole thing works, it's just it kind of maps to the entire life of that big IP. At the beginning, you need a license. You need some set of configurations in order to get things working. And then when it's over with, you probably don't need the license anymore, and then we can terminate the instance.
Mm-hmm.
And then kind of looking inside of, what does that code look like, at least from a Terraform standpoint. If I switch to my Terraform screen right here, kind of looking at just how things are set up right here, very clearly it's labeled, we have this lifecycle hook right here. And in this case, we have two of them. One mapped to our EC2 instance launching event, and then the second one mapped to our EC instance terminating event. And what I'm doing, at least in this case, because I can't send these lifecycle hooks directly to Lambda, because there's a message that has to get sent, I'm using this service called SNS, or I think it's a simple, no, it's not simple message service, simple notification service. That's what it is. But what SNS does is it just directly hands over basically the data that the lifecycle hook is trying to explain about the instance that's getting spun up to Lambda. So it's just passing data on. And then one of the things that I did as part of this project too, that if it's something that you're interested in, if you're interested in looking at Lambda, is deploying the actual Lambda function inside of a Terraform template. So this is something I actually had never done before. I'd used other frameworks to deploy my Lambda functions. But just as kind of one big, huge template, again, one of the things that you can do as part of Terraform is you can actually deploy your Lambda functions, in this case, my lifecycle hooks or my Python code that I'm using to execute my testing, and then the uploading of the AS3 declarations to my device. So one big, awesome template that kind of does everything in just one package.
That's kind of awesome because it's easier to, have everything on the, in the kitchen sink together rather than, it's like, oh, I need that from that cabinet and that from that cabinet. Yeah. And, because that's some of the complexity of all this, right? It's like, oh, I need this component with Terraform. I need this component with AWS, Ansible. And then I need to I got my own personal jump scripts to kick this thing off. And, it can get pretty complex pretty quick. So having the ability to, marry it all together into a single template is pretty awesome.
Yeah, and honestly, what the alternative looks like, and this is something that I've done in the past when building my own custom web application, is I used what's called the serverless framework for Lambda, which is actually a pretty solid framework. There's nothing wrong with the serverless framework. And then I use Terraform for basically any of the shared resources outside of Lambda, like my database and like some IAM permissions and maybe I think there was an S3 bucket in there that I used, but anything that was outside of basically Lambda, I use Terraform. And to get those two things to work together, it's kind of tough. There's tricks to do that using, in my case, I use parameter store, but to your point, Jason, it's easy just to have one place that you can kind of do everything. And luckily Terraform, at least in this use case specifically, it kind of handles everything.
Yeah, that's cool.
Yeah, that's awesome. It's awesome.
Cool. So going to lifecycle hooks, looking at that, we revoke our license. The next thing that I kind of wanted to look at, and again, just some tips and tricks of features at least to look at when you're using autoscaling groups. One of the things that was kind of introduced about a year ago is this thing called an instance refresh, and I'm going to show this off in just a second. But what an instance refresh basically does is it does what's called a rolling deployment, or a kind of a refresh of the different instances that you're running inside of your auto-scaling group. So, let's take the use case of, and it's in the diagram right here. I'm running 15.1 right now, but I'm at the point where maybe there's a feature in 16.0 that I want to upgrade to, or that I want to upgrade to 16.0. How can I do that with the least amount of impact for my users? And that's kind of what an instance refresh does, is it effectively, gradually, as we can see right here, goes through each of these instances and basically updates them with a new image for the new version of Big IP. So we're running the 15.1 image and we need to go to the 16.0 image. That's what an instance refresh does. And it also runs it through kind of that lifecycle hook process we showed a second ago. So as it spins up those new 16.0 instances as part of this instance refresh process, it also puts the new configurations on there, the latest, greatest configurations, does the testing, all the things that we saw just a second ago, but on that new version of Big IP. But in order to do this, and this goes to your question earlier, Jason, around, maybe I want to do kind of like A/B testing, or I want to do a comparison between one version from the other. You can kind of do that a little bit with this instance refresh functionality. So to kick this off, the way that I do that is if I go to this auto scaling page right here, and go into my auto scaling group for my big IPs, and I'll show in a second how you can do this with Terraform. But in the console, if I go to edit for my group, and then, oops, wrong one. If I hit launch template edit, and then pick the new template that I want to use. So you can do it two different ways, either by version or by a template name. And in my case, I just created two different template names because, I don't know, I thought it was a little bit more straightforward and easier to understand. And what I created was basically this new V16 template. And again, what this is basically just the image or the AMI within AWS that has that version 16 code of Big IP. And what I'm going to do is update this. I have to add here to launch template. For some reason, it wants me to use spot instances every time I make this change. But if I hit update, what that's going to do is basically say to the autoscaling group, whenever you spin up a new instance, you basically want to use that version 16 piece of code. And then in order to actually spin up new big IPs to replace the old ones with the new version of code, what I do is go to this instance refresh page and then click on start instance refresh. And then what it's basically asking me is, what's the minimum amount of healthy instances? So what's the percentage of minimum healthy instances that I want available as part of my auto scaling group? And so the way to kind of look at this is, the more aggressive you want to be, the lower the number. The less aggressive, so the slower it takes, and the less risk, I would say, the higher the number. But in my case, I'll make it 50-50. So I want to ensure that 50% of my instances are available. And then it asks, what's a warm-up period that I want? So how long do I want this instance to kind of sit there, wait until it can take on traffic? And I can leave it at 600 for right now. But Jason, to your earlier point around, like, maybe there's at some point I want to test this thing. Maybe I want to, spin up a certain number of instances, and I want to test, against two of the instances that are running 16.0 before I want to move on and update the rest of them. One of the things that you can do is enable this checkpoint functionality, which will basically create a checkpoint or a stop in the instance refresh process where you can go in there and actually test some things out before you move on as part of the process. So all kind of AWS native, kind of neat that they added this functionality, but just kind of calling that out.
Yeah, that's really cool. So yeah, if you wanted to shift 10% of your traffic onto, say, the latest big IP and say, okay, well, if you start to get complaints that, hey, something's not quite working right, and you say, oh, where are they flowing through? And you can kind of check that. It's like, oh, that's our new one. Maybe we didn't do the config right, or maybe there's a bug, or Not that we have bugs ever in our products,
no.
'cause that doesn't happen
Never.
with anybody's products. It's
No,
everything
those are
arrives.
features. Those
Right.
are features, Jason.
Features, right? So, but yeah, bugs happen, right? And so new product comes out, and you shift to it, and you want to test, make sure everything's good, because sometimes what you test in the lab, if you don't have the capability to test like production, things get missed. So that's really cool.
Yeah,
Yep,
that's a super cool
absolutely.
thing.
But what I'm going to do here, I'm just going to click start, and we'll kick off this process. There we go. Clicking on the wrong screen. If I click start, it'll probably take maybe an hour to finish this process, but it will update me as it's updating those new instances, kind of what we see here. So as the percentage completed goes up, it will basically tell me that, and it'll tell me the amount of instances that are left as part of the update process. But kind of the one final.
So is that an active process then? Then it starts kicking off a refresh instantly. I was thinking that maybe that worked like when instances are torn down because of scale up or scale down, that they would be replaced in that. But you're saying that it's going to actively shift them out, right?
Yeah. So this is you aggressively saying, hey, I want to refresh these now.
Gotcha.
Although I will say, if you are willing to wait for the auto scaling group to do its thing through its scale outs and scale ins, you can certainly do that too, where it will get rid of those old instances and then eventually replace them with the latest code. In the case of Big IP, that may not be a big deal, because for most folks, the configurations that they have, it's going to work the same regardless of version that you're running.
Right. Yeah, I guess it makes sense. Just from a ops perspective, it's like, hey, I actually want a window of when I'm going to be able to go home and not think about getting woken up at 3:00 in the morning because things broke on a Friday, so being able to plan that window a little bit.
Yep, absolutely. And, two other things I'll call out too is, so from a instance refresh, like trigger standpoint, you don't have to kick it off in the web console. So, if you want to make it as part of a larger CI/CD process, or maybe you want to be on the boat and you want to be on your phone and you just want to hit a button or type in a command. There's many different ways that you can execute this instance refresh process. You can certainly automate it. Everything in Amazon has an API endpoint, or almost everything. And then the other final thing I was going to mention just around this too is, at least when it comes to this instance refresh functionality, it's also inside of Terraform. So as part of my auto scaling group right here, one of the things that I can dictate is basically, what do I want to do when I'm doing an instance refresh? So when I go from one launch template to the other, what's kind of that policy or that strategy that I want to take to perform those replacements? And you can effectively kind of dictate that as part of your Terraform template right here also. So it's all in code. You can make as part of your code. Hopefully it's pretty straightforward if you want to do that.
Yep, for sure. Yeah, I was looking for a comment when you were talking about doing it from your boat. Daniel had mentioned earlier, it's like, Alexa, prepare for Black Friday. It's like, just call out your Lambda functions, but yep, hit that easy button from the boat or whatever.
So, story about that really quick. I know we're over now, but apologies. But I used to, when I used to have to do demos in front of people around like automation, like to, kind of encourage people to look at, writing code and to automate. One of the things that I did is I took one of those IoT buttons, if you remember those from Amazon. They used to have these little, I think they were called dash buttons. And you would hit it and then it would like order something. But they had custom ones where you could write your own code, and you would hit the button and it would call a Lambda function. And in my case, I did something silly where it like built out a VIP, right? I'm like, well, it's easy as hitting a button now. But not a great use case, but it shows the power of code, right? You can go from hitting a button to doing kicking off some complex process. Mm-hmm. So I think that's the dream everybody has, is how do I turn my maintenance windows into hitting a button and hopefully not worrying about it.
Yeah, for sure.
But I think one final thing just to kind of mention about this too that I forgot to mention is this NLB right here. So one of the things that actually does as we do this instance refresh is it will drain connections off of the old instances, hopefully gracefully. So in a perfect world, right, your users aren't going to see like random disconnects as an instance goes down as part of the refresh process. Hopefully it drains those active TCP connections and moves them to the new instances. So calling that out too, if that's a concern.
Mm-hmm.
Yep.
Yeah, that makes sense.
And then kind of the one final thing I wanted to talk about before we talk about ice cream a little bit more is I forgot to talk about the ice cream stuff, but the final thing that I've been kind of playing around with is really just this new feature that was introduced to autoscaling groups around 2 to 3 months ago, so back in April. And what this is about is really around the question of how do you make the process of spinning up a big IP or really any application that you're running as part of an autoscaling group faster. And what AWS introduced about 3 months ago was this thing called a worm pool. And the idea of a worm pool, as we kind of see right here, is instead of when you spin up a new instance as part of an autoscaling group and immediately sending traffic to it, one of the things that you can do is basically kind of set it aside, create a hot pool or warm pool where when you need that big IP device, it's in the stop state, but hopefully you can start it up very quickly. And, all the configurations or most of the configurations are there in order to very quickly get it into service. But, kind of going back to at least our lifecycle process earlier, one of the cool things that warm pools at least introduced is an additional step as part of the warm pool process. So, one of the things that you can do is when you're setting up that warm pool instance, talking about, how do we make this thing as fast as possible? Well, one of the things you can do is kind of put a base configuration on that big IP device that kind of meets your organizational needs. So maybe we want to apply a license to it ahead of time, or maybe there's a set of very large WAF policies that we want to put on this device that take forever to apply to the device. Or declarative onboarding. Maybe we want to set up things like NTP and our DNS servers for the big IP ahead of time. You can do that as part of this warm pool process, as part of that life cycle, and then it will just sit there until a scale out event occurs, very similar to earlier, and then we can go in and apply maybe our latest and greatest AS3 declarations that have our big IP configs on them and test them and ensure they work, and go through that same process we had talked about earlier. But I think what's really cool about these, at least in my testing, is if it's kind of an edge case, right? Because I don't think a lot of organizations have that need for speed. It sounds funny, but need for speed. But if you do, one of the cool things about warm pools is you can basically cut the time it takes to spin up a big IP in half. A lot of that time is probably spent, getting AWS to reserve compute for you, and then the initial licensing process and a lot of things that declarative onboarding will do for you. But if you're using warm pools, a lot of those configurations, a lot of that reservation process is done ahead of time, and you can effectively cut this thing in half, and you have a big IP instance in 2.5 minutes, or less than 2.5 minutes. So it's again another feature that it's brand new. I haven't seen anybody use, but it's something to call out, right? And something to look at. And if this is something that you need in your organization as part of your autoscaling group, it's something useful as part of that larger toolkit.
Just out of curiosity, on the cost side for warm pools versus just running things all the time in that active standby, what do you have an idea of what that cost differential is?
Yes. Thank you for bringing that up. I forgot to bring that up. So no, that's a very good point. So here, let me get to I'll use this one. So, assuming this isn't a stop state, Amazon does not charge you for compute when something is in a stop state. So for this big IP, you're likely only paying for storage in this case. And the cost of storage for the amount of storage that you use for a big IP is close to, it's not nothing, but it's very, very, very low. it's certainly a lot lower than running that instance all the time.
Right.
So you get that benefit. And then if you're using pay-as-you-go licensing, at least from everywhere I have read, and everywhere I've read, and don't come at me if you actually have to pay for it. But everything that I've read, you don't have to pay for the pay-as-you or pay-as-you-go license when the instance is in a stop state. In the documentation I've read, I haven't gotten into the numbers and actually looked at my billing statement, but that's at least what I've read. So kind of calling that out too, and then kind of to this earlier example right here. If you're using BYOL, one of the things that you can do is effectively wait till you license it until you go from a warm pool to hot state. So if you don't want to have a licensed big IP in that stop state, which is completely understandable or understood,
Mm-hmm.
You can absolutely do that. So kind of calling that out too is just another option there.
Yeah, that's pretty cool. Because obviously, if you can cut 2.5 minutes out of your start time or your availability time, that's a pretty powerful functionality for the not casting off your users who are getting impacted by too much capacity on your existing scale, right?
Mm-hmm.
It's like if it gets too slow, I'm out of there. I'm a very impatient internet user now, and
we all are, Jason. Yeah, we all are.
If it's slow, I'm gone. So
yep. Yeah, it's like a couple of seconds is your time or whatever. Jason, I would argue, you said that's pretty cool. I would say that's pretty warm.
Oh,
yeah. Maybe put that in your database, Jason. Your database.
There you go.
Is super. That's fantastic, though. Yeah, it makes sense.
Well, Tyler, always this is I learn a lot, and I'm always amazed at one thing you do really well is you make very complex things simpler. Like it's you bring it into apples and oranges in ways that makes it, hey, you know what? I don't need to be terrified of that stuff. I can actually do this.
Don't be terrified of Terraform, right?
Yeah.
Don't be terrified of Terraform.
And to your point, and to the point of not being terrified of Terraform. So I forgot to bring this up earlier, but if you want an interesting use case of using Terraform, maybe a good place to start, you can actually check the state of ice cream machines, McDonald's ice cream machines around you using Terraform. So if you don't want to configure infrastructure or you don't want to configure cloud resources using Terraform because it's intimidating, and it is intimidating, it was for me, query broken ice cream machines, figure out if the local ice cream machine for McDonald's is broken near you. So there you go. You can use this provider for that.
Yeah. And Tyler, to that point, back on the previous, Terraform lab we did back in December, I think last year, you actually went into some detail on exactly how that one works. I think we joked at the time as well, where it's like, you don't have to use Terraform to know if the McDonald's ice cream machine is up or down. It's down. It's down.
Most of the time, that is true.
Most of the time, you're gonna be correct if you say it's not working right now. After 7:00, isn't that right, Jason? You said something about.
Yeah, they shut it all down after 7:00 for sure.
Shut her down. It's crazy. No, but that's fascinating to know. And like you said, Tyler, code can do so many things. From creating complex infrastructure to checking the ice cream status. So super cool.
Yep, absolutely.
Awesome, man. Well, Tyler, this has been awesome. And we've had a couple of guys say hi along the way too. So man, it's been a great interactive experience. So this is it's been a lot of fun today.
Yeah, sure. Absolutely.
Yep. Well, Tyler, thank you so much. We'll catch you again soon, I hope. With the latest and greatest. I know you were sharing a couple other crazy things you're working on, so I look forward to being able to share those with the community down the road. Take care. Have a great day, Tyler.
Absolutely. Thanks, guys. I appreciate it.
Thanks, Tyler.
All right. That is not what I intended to do. There we go.
There it is. We wanted to see more of the ice cream machine Terraform stuff, or the warm, the warm pool.
That's right. So I wanted to bring up, you guys were talking about the Terraform lab from December. That's the link for that lab. If you haven't seen it, go watch that show. Register for the lab at WWT. Consume that. Dig in. It's good stuff.
Yep. Yeah, it was a lot of fun. lot of fun, really great feedback from that. Just a good intro to Terraform kind of stuff. So,
yep. And Daniel, thank you. And really, I'll say thank you for Tyler because he made the show awesome for sure. And
And
to Josh,
we'll use Alexa. Yeah. But anyway,
right. Josh, we missed your call out. Good to see you as well.
That's right. Yeah, man. Yeah, lots of great interaction today. This is a lot of fun. And at one, if I may, Jason, this is back kind of earlier in the show, but Boris had said, "What's up?" So Boris, if you're still out there, my friend, what's up? That's awesome. And then there was a Facebook user that simply said, "Peace." Maybe I don't know if that was like a peace out or just, hey, peace to the, to this DevCentral Connects moment, right? Yeah. And then Deepak, good vibes to you too, my friend. Good stuff.
Yeah, that actually made me think of the Good Vibration song, and I started like singing that in my head a little bit. And it's like, wait, we're doing a live stream. I need to be paying attention.
Well, you were paying attention. You were paying attention to the song in your head. That's right. Arguably, that's a good thing, right? So it's good stuff.
That's right. So yeah, just a reminder, next week, 12:30 Pacific, we're back here. DevCentral Connects again, MITRE ATT&CK Framework. It'll be a great show. He's still here.
Boris, good stuff. Right. Good to see you, man. Good to see you.
and Josh got in there before we close up shop. Warm pool sounds cool. And the Lifecycle hooks are cool as well. So I'll have to dig into those a little bit more. So anyway, thank you, community, for joining us. As always, we are here for you. So if you have show ideas, concepts you want to talk about, technologies you want us to explore and bring experts in on, let us know in the comments, and we'll do our best to get that on the docket for the future. So, for those who are still experiencing 40 degrees Celsius, stay cool.
Stay cool.
Yeah, stay cool. Hopefully you have air conditioning. And that's the thing. It's like I gave everybody in the Northwest a hard time. It's like, I'm chilling here in my fantastic air conditioning, because I mean we have that kind of heat all the time, but we can get out of it. So
that's right. Most people in the Pacific Northwest do not have central, air conditioning. Yep. So it's a tough one, but yeah.
Yep.
Well, yeah, man. Well, Jason, it's been a great show. Like you said, man, it's always good to connect with everybody, and we'll be back next week with the MITRE ATT&CK framework. So that just sounds cool,
It really does.
Sounds awesome. It's going to be a lot of fun.
Well, John, I will see you again soon. Community, we'll see you next week, 12:30 Pacific.
Thanks, everybody.